Okay, so now everything is set up. So let's dive into the slides. So as usual, I will be giving you the list of topics which we are going to cover in this day. So the first topic, we'll see what is a process, because it's a big debate like thread is good or process is good, or multi-threading is good, multi-processing is good. So basically, these two things belongs to multitasking. So if you want to perform some multitasking, you will either go for multi-processing, or you will go for multi-threading. So we will see what is a process, what is a thread, and then we will see what is the difference between a process or thread. Basically, it will be a war zone sort of thing, and we will decide which is better, process or thread. And then we will see need of multi-threading, why we actually need multi-threading. So people who don't have any idea with multi-threading will get to know. And then there is a thing known as POSIX thread. So yeah, uh, अभी के लिए इस पे रुकेंगे, what is POSIX and all these things. So I will explain when we reach the point number 5. And finally, we will do some practical demo. This is not a theoretical live session. I will keep it practical. So we are going to write some program and see multi-threading working. So excited, ready? Yes. Few things about C and C++. Yes, sir. Let's go. Cool. All right. So the first thing is, what is a process? So in a very layman terms and in very simple words, I can say a process is any program in your machine which is currently executing. So yeah, any program in execution is a process. So if you're watching this live, some process is happening behind the scene. The Google Chrome browser is running, or whatever browser you are using is running. So some process is happening in your system. So that's a process. And process need to be loaded into the main memory. So if you want this process to be executed, it need to come inside the main memory. And in main memory, it has 4 sections. The 4 sections are the stack, heap, the data. Sorry, it's not date, it's mistyped here. It's data and text. So these 4 sections are there in the process. So it stores data accordingly. Like if this data need to be saved in a stack memory, it will be go inside stack. If it's dynamically created, it will go inside heap memory. If it's global variables and explicit variables, so they external variables, sorry, they will go inside the data memory. And text will have your normal code or whatever text you have for your program. So these are the 4 sections in the memory of a process. So that's all the process is. It's a very simple thing. And thread is even more simpler. So sometimes people think thread is a difficult thing to understand, but it's not. So actually, threads are nothing but the lightweight process. Okay, threads are nothing but a lightweight process, and each thread belongs to exactly one process. So any point of time, at any point of time, a thread will only exist inside a process. It can't exist outside a process. Okay, so if you have a process, it can have multiple threads running inside. So if I take the example of your Google Chrome browser only, so launching the browser, executing the browser background activity is a process, and in this process a lot of threads are running. Actually, all the tabs you open are different threads of Google Chrome browser. So if you are on a Windows operating system, so you can see the task manager. And if you're on a Linux, you can run the top command. So you will get to know ki, okay, I have opened these many tabs and these many threads are running actually. So yeah, cool, makes sense. Great. And each thread represents a separate flow of control. So yeah, like process, they are actually sort of independent. And yeah, the fourth point is very very important in terms of programming. So for developers is important, the data segment of process is shared by all the threads. So remember, I told you in the previous slide, these 4 sections are of a process, and the data is actually shared by all the threads. Okay, and what sort of things go inside the data memory are your global variables, right? So that's why it's highly recommended to not use global variables while you are dealing with multi-threading. Okay, and in case if you are using multi-threading and using global variables, you need something known as mutex. Can a thread access any other process data? Or this is not possible. This is not possible, Sanjeev. Thread cannot access data of other process. It can access data only um, which is present inside the process in which thread exists. Yeah. But yeah, thread can access data of other threads. So as I told you, if you have global variables, that data will be that variable will be shared by all the threads. So yeah, you can use that common variable. Okay, makes sense till here? Got it. Awesome, amazing. Thanks for your inputs. You're really good going. Okay, so now let's see what is the versus process versus thread thing. So process are generally heavy because whenever you load a process, you need a lot of resources. So for example, you need memory. Of course, you need a memory to run a process. And maybe if that process is dealing with the input output, so it needs input output devices. If that process needs some file reading sort of thing, it need that file. So it's a very heavy thing that a process demands before running. But a thread is very light because the process is already in the running stage. Thread is very light. It will just open, do its job, and then close. That simple threads are. And the context switching is very faster as compared to your thread as compared to your processes, because in process if you want to do context switching, so you need to block running process and then start another one. And but in thread they are independent, so if you don't need to actually block the running thread and then access the data. It's just if you want to context switch, you can do that. You can do that. So it's very simple in threads. And finally, the process are dependent on each other. Yeah, of course, process are dependent on each other, and but threads are independent, as I just told in the previous point. So these are the process versus threads, and I hope you can now make the decision on the winner. So threads are the definite winners. Global data is shared among all process and threads. No, global data is shared amongst all the threads, not the process. Can a process swans another process? Um, Maybe. I will say it depends what we actually are doing with that. Vikram say it's this is clear. Okay, amazing. Cool. So I guess next thing is your okay the need of multithreading, and then you will get to know about that big boom sort of thing. So let's see the need of multithreading. Actually, the need of multithreading is very straightforward. Only we do multithreading only for one thing, which is to improve performance. That's all. That's why we need multithreading. Okay, to improve performance. So how multithreading improves the performance? Because it will um, you know run the multiple things, or you can say multiple threads concurrently. So there is some sort of parallelism. So if you can do multiple things parallelly. Pavan says communication between threads is faster as well. Yeah, great point. That's what I mean with the context switching sort of point. Yeah. Okay. So need of multithreading. We need multithreading to improve performance as provided. Uh, Ability to execute multiple threads concurrently. It also leads to minimization and more efficient use of computing resources. Yeah. And finally, application responsiveness is improved because we are running a lot of things parallelly. So definitely the response time will decrease, which will increase the again performance. So the very simple answer why we need multi-threading is to improve performance. That's why we are doing all these things to improve performance. That's what we want from our application. Awesome. So I think now you know what is a process, a thread, what is the difference between them, and why we need multi-threading. So any question, any doubt? O- Okay. I found no questions. So yeah, now we can go further. Okay. So now let's see what is a POSIX thread. So before diving, the first point, read the first point. It says C does not contain any built-in support for multi-threaded application. Today's live is about multi-threading in C programming language, and I'm saying C does not have any support for multi-threading, and that's the boom factor. Yeah. So to do multi-threading, it's not like you can't do multi-threading in C language. We can, but actually the built-in thing is not there. Like in Java programming language, you have multi-threading support in the language, but for C, it's not there. Okay, so how we do multi-threading in C? We are totally dependent on the operating system. Yes, we are totally dependent on the operating system, on the OS to perform multi-threading. So that's the standard is known as POSIX. That's why it is known as POSIX thread. So whenever you listen someone's talking about multi-threading in C, so now you know the multi-threading concept is not inside C language. C language uses operating system. It's totally dependent on operating system, and the standards it follows is the POSIX thread. Okay, so let's read the further points. So the first point is C does not contain any built-in support for multi-threading application. So you can't write uh, a sole program in C language which do multi-threading. It relies entirely upon operating system for multi-threading. And then third point is POSIX thread, or more famously known as P threads. Yeah, I hope someone have um, at least few people have heard about this term p threads. Yes, no, p threads सुना है पहले कभी? Nope. Okay, I thought they are quite famous. Okay, so POSIX thread, or you can say p thread. I have heard. Yeah. Okay, so what does what it does actually? So they provide API, and yeah, API again, application programming interface, which on which I talked about in the previous live. If you have missed, you can go to the YouTube channel of educators and watch the recorded session there, or you can watch the recorded session on Creator itself. API are very important in today's world, so must watch video. Okay, so POSIX thread also provides you API, a simple bunch of functions that you will call and create your threads. Okay, so pthread provide API which are available on many Unix like POSIX systems, so such as free BSD or NetBSD, GNU Linux, of course, macOS, and Solaris, etc. A lot of operating system supports POSIX threads now. So currently I'm on Mac OS, but the same program will behave exactly if you if you compile in Linux and then run it. Okay, so the library we need is the pthread. Okay, so there is a library known as pthread.h, and you don't need to download it externally. If you are using GCC compilers, it's already been there. Okay, so no worries for installation part. If you are using GCC, which I believe everyone is using GCC, don't go for that turbo or whatever. Go only for GCC. So yeah, that's your POSIX thread. And without wasting any more time, let's dive into the programming part. So I just wrote a couple of things here. The first thing is operating system you need is Linux or Unix. I guess it does not work on Windows. I don't work on Windows anymore, so I have no idea. I haven't run any multi-threading program on Windows. But yeah, on Linux, Unix, definitely it will work. For sure, it will work. So can you give me a quick yes, no's, or can you write your operating system in the chat window? What operating system you're using? You're on Mac, Linux, or Windows? Sanjeev is on Mac. Okay, Linux. Yeah, I love Linux. I just use Mac for all these meetings, live streams, but most of the time I spend my time on Ubuntu. Akshay is on Mac. Great. Okay, great inputs. So now we know we all are on Linux, either on Linux or Mac, so it will work for us. Maybe Windows people are like, we can't write now. If anyone is on Windows, please switch to Linux. You are a developer. And if you don't know how to switch, again go to the Educators YouTube channel and you will find a couple of videos there. Okay. So first point is clear. Operating system we need is Linux or Unix. The second point is, can you share links? It's just educators. Now these days, YouTube started this at the rate or handle sort of thing. So if you write at the rate ADUCATORS, you will find me all over the place on the educators YouTube channel. Okay, so if you ask link, let me see if we have. Mm-hmm. Here it is. I'm just pasting in the chat window. Yeah, done, Pavan. Okay, so second point is the library for POSIX thread is pre-thread. So how we include another library is is the same way we include pthread. So hash include in angular bracket pthread.h. And how to compile this program? We just need to write GCC. As usual, you write any other program to compile. So GCC, your program name dot c, then hyphen l pthread, and then um, one second. Mock should say, hey, but C does not contain any built-in support for multi-threading application. Okay, sorry, you say sorry, I joined in late. Okay, yeah. Actually, we were talking about the exact point you raised right here. Yeah. So in the previous slide, I just talked about C does not contain any built-in support for built-in application. Great, you have some previous knowledge about it. That's awesome. So yeah, and here only I explain ki we need something known as POSIX thread, P thread. And yeah, cool. So C language totally depends on operating system. So POSIX thread actually make some deal with operating system and make multi-threading possible for us. Okay, and so this is the extra thing you do to compile your multi-threading application, which is hyphen LP thread, or if you just write hyphen P thread, it will work. Cool. So these are the basic knowledge you need before programming. So now we know all these things, we can jump into the programming part. Yeah, this is the document for your um, thread. Let me put that in the chat window. I highly prefer only go for documentation. Only read documentation. Don't go for um, misleads tutorials. Okay, so let's open the documentation part in one tab. I will stop sharing and now I will share my entire screen. So share the entire screen. Give me a second. Entire screen. Okay. Confirm me if you can see my screen. It says synopsis for p threads. This synopsis p thread and see. Yeah, great, awesome. So this is the library you need. So let me open the terminal. I hope everyone is comfortable writing programs in Vim text editor, or if you not, you can use any text editor for writing the this code. You can follow any notepad or whatever. So let's call this program multi, or let's say uh, multi threading. Let's see. So first we need the stdio because definitely we are going to do some input output sort of thing. We'll or at least printf sort of thing. So we need stdio.h and we need pthread, pthread.h. Fantastic part about pthreads, all the function, all the method starts with pthread underscore and whatever they does. So this is the common initial pattern of any pthread function. Let's write our int main. I'm not taking any command line argument, so we can leave that part. Mainly it will return. Yeah. So, and if any doubt occurs while I'm writing the code, just ping me. I'm just opening. Your chat window is open in front of me, so I will not miss any of those. Okay. So if anything, you can just write it here. Cool. So in main, we need pthread underscore t, and here we will create a first variable for the thread ID. So I will call thread ID. Let me show you the API, what function we are going to use. So there is a function known as create thread create. The function is here. So see the document of this function. It returns you integer p thread. The first thing it needs is the pointer to your thread ID, whatever it is, the one we created just here, and then it needs some arguments. If you don't want to pass any arguments, you can pass null here. It will definitely work. And for the simple examples, we will be providing null. And then you need to pass the function pointer here. So whatever the function you want to execute when this thread starts. And finally, the list of arguments. Basically, you will pass only one. So the argument that you want to pass to your function. Make sure that function returns void star. Okay, so here is a description. You can also read that description. I'm going to follow the same thing here. So I will say p thread create, and first I will pass the ID. Then I will say null because I don't want to pass any. Someone asked the question. Page is reloaded. Will you also cover semaphones and mutex? I guess I will reserve these topics for the next live because they are couple of things which I need to explain more for mutex or semaphores. Semaphores basically, semaphores and mutex are used basically for similar sort of thing, but mutex are more safer. Semaphores are uh, for me, I guess mutex are much safer because they are thread proofs, but semaphores are just if else statements, so I don't trust them that blindly. Okay. Okay, so now we need to pass the function here that we are going to call. The function will be, let's say, taskmaster. some funny name, and the argument list will be null for now. We are not passing anything here. Wow, one second. The chat window just dropped. Now it's up again. Okay, so after creating this thread, I will be writing a multi-threading program. Just bear with me. This is a very simple demonstration because you're writing the multi-thread program for the very first time. So here I'm just creating one thread, but then we will modify this program in this live only. Don't worry, and we will make it multiple threads. And finally, we will call the p thread join function, which is very much equivalent to the wait call. If you know about processes, in process there is something known as wait call. So yeah, join p thread join does the same job. Cool. So let me pass some p id, I guess. T id. Yeah. Great. Any question till here? We are going to create the task master right here. Any question in the code or any method you want some more explanation? Nope. Slightly hard, but still following. Okay. Okay, so let's do a printf statement and um inside this task master. Print inside um, thread function, or let's say task master. So let's put it on a sleeve or we can ignore the sleep. Yeah. Let's do a print statement inside the main only, where it will say inside the main before hitting here after join, we will say copy paste, we will say after join. So I try to make it as simple as possible. So what this program is doing, it has a function taskmaster and it has a main function, obviously. And inside main, we are creating a p thread ID. It's a variable of p thread type. This will be the ID of your thread. Yeah. Thanks then for all clear. Then we are printing a simple print statement that we are before the thread, and then we create the thread by calling the API function. This is the API function, and then we call another API function which says join, which is similar to the wait, and then we are printing again after the join. So that's all this program is doing. It's a very simple thing. It will just open a thread and it will close it. That's all it that that's all it does. Cool. So now let's go and compile this program. Name of the code was multi underscore threading. So as I told you, GCC, your program name, then you will write a hyphen p thread. You can write hyphen l thread, both works. I guess in the slides I mentioned lp thread. Yeah. Okay. You can go for lp thread or you can just write p thread. Both works. And then we need the object file as multi Oh, we forgot to put the semicolon. Thread ID, and then we need to pass null. But you need to pass two things to your pthread join. Let me show you the document also. Pthread. First it needs pthread, and then it's need void star double pointer. So we're just passing null for now. Ah. Oh, that's what we love. No warnings, no errors. And let's execute it. The name of the executable is, or your binary file is multi_threading. And see, it does more or less like the normal procedural program. Yeah, it prints the first line, then it goes to the task master and print the line inside the task master, and then come back and print the after join sort of thing. So it does a very simple task. Okay, so let me know if everything is clear. Yep, great. So now let's all good. Let's open a program which I have already. It says multi-threading without an underscore. This is the documented code. I found it in some documentation. I will be explaining you this one so that we can save a lot of our time typing the code. Okay, so I will be explaining you the written code. It's not written by me. It's from the documentation. I just grab it and bring it here to explain. Okay, so it's a very small code, only 44 lines are here. So here, what let's go to start. We are including some header files, stdio. Of course, we know for input output. stdlib, somewhere we are using sleep or some sort of thing. Assert, because we are using the assert function, and then pthread, which we need, and sleep, for sleep we are using this one, uni std.h. And then we have a macro known as number of threads. So in this application, we will be having 5 threads because we are running the loop for 5 times. Okay, so in this particular application, whose name will be multithreading.c, will have 5 threads. Okay, so now let's come to the main part. Here we are again using the threads. Similarly, like in the previous example, I created TID. So this is the array of those TIDs. Okay, so we have an array for all the thread IDs. Then we have array for the arguments. As I told you, you can pass a couple of arguments in the um, um, function. So that's why we are using thread arguments. Then we have the variable I for running your loop, and then result code we are saving the return value from the pthread create. Okay, so now this is a simple for loop. It starts from 0 and goes till number of threads, which we have here 5. So here it says in main, I'm creating a new thread and the number is I. So it will print 0. We are creating the first thread in here. Then the argument is assigned the value as I. So same number we are passing to the function. And here I'm calling the pthread function, passing the first, or you can say the 0th index ID. Then again, the arguments here are kept null. We are not passing or assigning any arguments. And then we are calling the function, or I'm saying you need to call this function, which is perform work with these arguments. So this is the argument, pthread argument at index I, which is currently 0. And then we will check assert if result code is success or not. So yeah, and it will keep on doing this thing for 5 times. Okay, and notice one thing, we are not calling the join function inside the inside this loop. So what will happen? It will keep on creating threads without waiting the previous thread to perform or to finish its task. Okay, as I told you, p thread join is somewhat similar to the wait. So we are not saying कि hey multi-threading program, you don't need to wait to my for my first thread to finish. Okay, you just create another one. Cool. And after completing, yeah. So after completing this for loop, I will come here and then I will run the similar loop for n times, or you can say number of threads time. And here I'm doing the join. So similar thing that we did for one single thread, here we are doing for 5 threads. And finally, I'm printing main program has ended. Let's have a look on perform work. It's a simple small program, small code. So perform work, again, it returns void star. As I told you, you have to make sure your program returns void star. Here we are creating the index. So the argument is of void star type. So we are typecasting back to the integer. Then we have a sleep time, and we are doing some funny thing here. We are calling the rand function and getting a random value, and then so that the program will go to sleep and for random um, seconds, random amount number of seconds. So p thread started, yeah, at a random time, for a random time, and then it will put that thread on sleep for random seconds of time, and then it will say end. Also make sure whatever output you're going to see on my screen may differ, and I will say will differ. Definitely it will differ when you run the same program on your machine. So because they are threads, it's not like the first thread will create, then second thread, then third, fourth, fifth. First thread will perform the task, then second will perform, third will perform. It's not like that. Threads are created. Any thread will get the resource, do the job, get resource, do the job. So that sort of things happen behind the scene. So yeah, definitely you will find the messages, all these messages, but definitely in mismatched pattern. So get ready for this. So let me see if I made any changes, and now I'll do the GCC multi-threading.c, and let's say p thread, and let's name our output file with the same name, multi-threading. Let's run it. Threading. Yeah. See, it says in main creating thread 0, creating thread 1, creating thread 2, 3, 4, and then thread 0 started. Thread 0 will be sleeping for 3 seconds. So my thread 0, which is the first thread, will go sleep for 3 seconds. And then in main it says all threads are started. Before finishing the first thread of work, or first thread work, it says in main all threads are created. My job is done. See, the for loop is executed successfully. Now it will start running the for loop, which would do the join part of thing. So here it start joining, and your previous thread will keep on working. Whenever they get the resource or time, it will print on the screen. Okay, it says thread 1 started. Thread 1 will sleep for 5 seconds. It get the random number 5. Now meanwhile, thread 2 got started and it got sleep for 4 seconds. 3 started, 4 seconds, 4 started, 1 second, 4 is ended, thread 0 is ended. Meanwhile, 3 seconds are done. So yeah, even if I try to run the same program, the output will differ or may differ. So you can see I'm running this program again, and see, this time we got not that nicer. See, two threads created. Thread 0 started working before even thread 2 got create. See, it got started and went to sleep for 3 seconds. So yeah, that's I was telling you. Okay, so definitely if you get this code, um, Interesting. And also for sharing the code, these codes that I use in live demonstration, what I will be doing, I will be creating a Discord. So if you yeah, so I will highly suggest you to join Discord. The Discord link will be dropped by EOD in the WhatsApp group.